Projectile motion. That is a very important concept in physics. Projectile. Projectile is when something is thrown from the ground at some angle. If it is thrown vertically upward, it will go to some height and then it will come back vertically again. But if it is thrown with certain angle with the ground, it will go up to certain height and fall at some distance following a curved path, which is called a projectile. So that curved path is projectile. But question is why it is so? Why it is taking this type of curved path? Now just imagine if there was no gravitational pull, if there was no gravitational acceleration due to gravity, then if it is thrown with u, it would have gone in straight line as shown in the picture. From O it will go to P, Q, R, S, T, like this it will go in a straight line. But thing is, every time it is pulled down by gravitation, and the more and more time goes, it is pulled down further and further. So at P it is pulled down to P dash, at Q to Q dash, at R dash, and S at S dash, at T dash. That means every time the pulling down is increasing with time, and by this process the path takes a curved path which is called projectile. So the path bends due to gravitational effect only. Now we will try to deal with this projectile, because this projectile is a two-dimensional motion. So it will be dealt with accordingly. So here what we have done is we have taken the vector method. Now the velocity, initial velocity u, can be resolved into two directions, x direction, that is along ground, and y direction along vertical line. So let us take it as the vertical component and horizontal component. So there will be u sin theta and u cos theta. So we can write u vector as u cos theta into I cap, that is the unit vector along x-axis, and u sin theta plus u sin theta into j cap, which is the unit vector along y-axis. Similarly, after time t, what will happen? This u cos theta is horizontal. So it will not be affected by the gravitation because it is at 90 degree. No acceleration can affect any velocity which is at 90 degree with it. So u cos theta will not be affected. It will be all along constant. But u sin theta is in the line of g, and g is in opposite direction to u sin theta. So u sin theta will gradually reduce with time. Now if we take v also in ij form, then v we can write as vx I cap plus vy j cap, and that vx will be v cos theta only, because u cos theta will not change any time. So at any time t, the x component will remain as u cos theta. So we write v cos theta, u cos theta I cap, plus the vertical component u sin theta will be reduced, because if we apply the kinematic equation, it will be u sin theta minus gt in time t. So in time t, the velocity will be written in vector form as u cos theta I cap plus u sin theta minus gt j cap. Similarly, if we write displacement vector as s, that also have two components. One component is horizontal, which is due to the horizontal velocity, which is a constant, so that will be u cos theta into t simply. But the vertical velocity has an acceleration. In fact, this acceleration is in opposite direction to u sin theta. So vertical component in time t will be u sin theta t minus half dt square. So s, the displacement, we can write u cos theta t I cap plus u sin theta t minus half dt square j cap. So that means u has two components, horizontal u cos theta, vertical u sin theta. V has two components, horizontal u cos theta, vertical u sin theta minus gt. S has two components, horizontal u cos theta t minus and vertical u sin theta t minus half gt square. So these are the things we have arranged first. Next we will find flight time. Flight time is the time when it reaches the ground again, means when it reaches at A in this diagram. From A it is projected, it reaches at A after the curved path. So this time by which it reaches A is called flight time. So we have to decide one thing. See, at O and at A, both the times it is on the ground. Means its vertical displacement from ground is 0 at both the time. Sy is 0 both the time. Now, what is Sy? Sy is nothing but u sin theta t minus half gt square. I have seen earlier. So that will be 0. If we put that equal to 0, we find u sin theta t minus half gt square equal to 0. This is a quadratic equation of t, and so t will have two values. One will be 0, and which is for initial value. That means at O. When at O, the time is also 0. The other one is the time for reaching to A, and that is the flight time. So from the above equation, we get t equal to 2u sin theta by g. That is the flight time of the projectile. Now, if we have to find out the maximum height, what is maximum height? Here maximum height is b, when it reaches at b. Now, when it reaches at b, let the height becomes h. So, a capital H, that becomes the maximum height. At b, the velocity of projectile is horizontal only, because it is always along the tangent. So, their tangent is horizontal. So, at b, it has only horizontal velocity. Vertical velocity is 0. That means Vy, which is u sin theta minus gt, that becomes equal to 0. If we put u sin theta minus gt equal to 0, we get t equal to u sin theta by 2. That means this is the time when the projectile reaches the topmost point. Now, by putting this value of t, if we find Sy, because capital H is actually displacement in y direction when it is at maximum height. That means it is Sy in time t as reduced just now. So if we write the equation of Sy is y component of S, which is u sin theta t minus half gt square. Now if we put the value of t, we will write Sy equal to what? We will write u sin theta into, in place of t we put u sin theta by g. So u sin theta into u sin theta by g minus half gt square, half g into u sin theta by g whole square, means u square sin square theta by g square. By calculating this, we will find the value of h is u square sin square theta by 2g. So this is the value of the maximum height. Last thing is range. What is range? Range is the length OA. What is OA? OA is the distance in x direction in the flight time. Means at the end of flight time it will reach at A when there is no vertical displacement, but there is a horizontal displacement in x direction, which is given by A. So it is actually the horizontal displacement in the flight time. So we write the horizontal displacement formula which is nothing but u cos theta into t, because here we have seen S has a x component u cos theta t I cap. So we write here horizontal displacement as r, we write u cos theta into t, that t we put as 2u sin theta by g, which is the flight time. By this we will find it is as 2u square sin theta cos theta by g, which is nothing but u square sin 2 theta by g. So by this we find very easily the flight time, maximum height and range by applying vector. And in fact, using vector is always very easy in mechanics. So I hope you have understood this. This may be done without using vector also, but I think, in my opinion, by vector you will find it easy to find these three variables. So this is all about today's topic. I hope you have understood. Please note down this and or repeatedly look at this so that you can understand and you can keep this formula in memory. So this much today. I will come to you again with some other concept, and thank you for listening today. I am stopping here.